from Ammar STEM School. We are going to do an activity experiment on these two blocks. These two blocks are connected with a light string passing through a smooth poly on a rough surface. The plane is inclined to a horizontal plane with a 20 degree. Using this force sensor and the basketball stone program on the laptop, we are going to find the maximum force needed to move the small block over the large block down.
Hello, my name is Ibrahim from Ammar STEM School. To do our experiment, first of all, we will reset the force sensor by pressing on the zero button. Now we will pull the force sensor to make the small block about to move. The friction force between the two blocks will be upwards in the direction of tension force. And the friction force between the big block and the plane will be downwards opposite to the direction of tension force. Now I will pull the force sensor and Ammar will record the results. Our block is about to move. Ammar, what is the maximum friction force?
It's 0.9 Newton.
Okay, we will reset our force sensor again and make the second trial. Record Ammar, please, results.
Okay. It's 1 Newton.
1 Newton. I will reset the force sensor again. What's the results?
1.1 Newton.
Okay, very good. Reset our force sensor. Record Ammar's results, please.
It's 1.2 Newton.
Okay. We will make the fifth trial and that's the last trial. But before that, again we will reset our force sensor. What's the result, Ammar?
It's 1 Newton.
Now my partner Hisham will make the theoretical analysis for this experiment.
Hello everyone, my name is Hisham. I am from Ammar STEM School. Now we are going to do some calculations about our activity problem. We have two blocks. The large block is red and the small block is green. We got the mass of the small block 63.66 grams and we convert it to Newton. That's equal 0.624. And we got the mass of the large block. We got it 129.28 gram and we divided it to Newton and get 1.267. And we summation these two weights, get W total equal 1.891. Now we will resolving the total weight we get in the normal and tangential direction. We have the normal equal Wt cosine 20 and the tangential Wt sine 20. When we make and apply force in this direction, we pull it and the tension will make the large body about to move upward and the friction force will be downward. We get from the first case T equal Wt sine 20 plus Fst. That's equal Wt equal 1.891 times sine 20 plus 1.8 times 1, that's total weight, times cosine 20 times 0.23, that is the coefficient of friction of the large body on this inclined plane. Then T will be equal 1.06 Newton and this number 1. This is the second case. We will work on the small body. We get the normal is Ws cosine 20 and this is Ws sine 20. And we will apply force here. When we apply the force here, we will have Fs in the opposite direction. So we will get this equation. F applied plus Ws sine 20 from here equal T plus Fs, friction force. Force applied equal T plus Fs minus Ws sine 20. T, we get it from the first case, equal 1.06. We sum it with 0.624 times cosine 20 times coefficient of friction, that is 0.34 minus 0.624 sine 20. Then we get F applied equal 1.05 Newton.